nature of bonds. Okay, nature of bonds. B2H6, B2H6. Diborane contains 2BH3. Diborane contains 2BH3. 2BH3. Okay. Units is that it is the dimerization product. Okay. Of BH3, the electronic configuration of boron atom is given as below. Boron B5 equal to 1s2, 2s2, 2px1, 2py0, and 2pz0. Okay. Then in 2s, s orbital, and this is p orbital. In p orbital, 3 orbits. In 2 electron, 1 electron, 2 electron, and p orbital only 1 electron present here. Okay. B in ground state. B in ground state. Okay. And after some time, this is also converted like this. One electron and 1 electron transfer to p orbitals. Okay. And this is a 2s, and this is 2px, 2py, and 2pz. This is sp3 hybridization. sp3 hybridization. This is sp3 hybridization. Which hybridization? sp3 hybridization. Okay. 1, 2, 3. 1s and 3 p hybridization. Hence, due to sp2 hybridization, this is sp2 hybridization. Okay. And hence, due to sp2 hybridization in BH3, the structure is triangular planar. And there is one empty pz orbital, and the structure of B2H6 can be illustrated as follows. These: boron, hydrogen, 1 hydrogen, and 1 hydrogen. This is pz plus boron, 1 hydrogen, 2 hydrogen, and this is 3 hydrogen, and this is pz. This is pz. This is equation number first. B is sp2 hybridization. sp2 hybridized. Okay. sp2 hybridized. And this is the first figure. In second, we see that this is boron. 1 hydrogen, 2 hydrogen, and this is pz. This is pz, and this is hydrogen, H positive ion. Okay. Hydrogen, and this is a boron. This is boron, H positive hydrogen, and this is pz, hydrogen. This is hydrogen ion is separated. Hydrogen ion is separated. Hydrogen ion is separated. Okay. Hydrogen ion separated. In next hydrogen are separated, okay? And in next figure third, you know, this is a boron, one hydrogen, two hydrogen, and this is sp3 hybridization, okay? And this is boron, one hydrogen, H positive ion, and this is H positive ion, and boron, one hydrogen, okay? This is sp3 hybridization, okay? This is sp2p hybridization occurs and sp3 formed, okay? sp3 formed, okay? And after some time, this is in fourth figure, this is boron, and this is boron, one hydrogen of this and one hydrogen, two hydrogen, and one hydrogen, okay? And after some time, this is H positive, and this is H positive, okay? sp3, and this is sp3, this is sp3, and this is sp3 hybridization, okay? In fourth number figure, sp3 overlap occurs, and this is boron, one hydrogen, two hydrogen, three hydrogen, and four hydrogen. This is H positive ion. This is H positive ion, okay? This is H positive is flungate. H positive is flungate in the charge cloud. Okay? And after some time, this is also convert as light. 1 minute. Boron, okay? Hb, and this is Hb. Bridge hydrogen. This is bridging hydrogen. Okay? And this is hydrogen 1, 2, 3, and 4. And 4. Okay? This is figure number 6. This shows hydrogen bridge is formed. Hydrogen bridge is formed. Hydrogen bridge is formed. Okay? And the hydrogen bridge BHBB in diborane is treated as a 3-center 2-electron bond, 3-center and 2-electron bond. Okay, this bond is formed by 2 electrons which bind 3 nuclei together. Thus, diborane molecule has 2 3-center and 2-electron bond. 3-center and 2-electron bond. That is hydrogen and boron and boron. Okay, this is orbital model of 3-center bond. Okay, and this is boron, hydrogen and boron. B point. This figure is A and this figure is B. This figure is B. Okay. This is a delocalization of sp3 electrons. Okay. Delocalize of sp3 electrons. Okay. sp3 electrons. And this is boron, one hydrogen, and one hydrogen. Okay. One hydrogen and one hydrogen. Okay. This is a banana bond in diborane. This is banana bond in diborane. And the overlap of sp3 gives tau bond. The shape of tau bond is like banana, and so it is also called banana pi bond. This is banana pi bond. Thus tau bond is a special case of pi bond. Tau bond is special case of pi bond. Tau bond is special case of tau bond. Okay. And as a hydrogen positive ion is present in the charge cloud, the bond is also called promoted pi bond. The bond is also called promoted pi bond. Promoted pi bond. Okay. The structure of diborane can also be explained with the help of this figure, in which represents the electron of boron, where is oxygen indicates, where is O indicates electron of hydrogen, 3 center bond is represented by two dotted loop. Two dotted loop. In each loop there are two bond, two boron and one hydrogen and two electrons. You can show this is boron, this is boron, this is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen, and you can see this figure. This is hydrogen, this is hydrogen, and this is okay. Three center bond. There are three center bond. This is show electron of boron atom. This is show electron of boron atom. This is show electron of boron atom, and this show electron of hydrogen bridge atom. Hydrogen bridge atoms. Hydrogen bridge atom. Three center, two electron. This is three center and two electron bond in diborane. Okay. This in which represent the electron of boron, where is O indicates electron of hydrogen. Three center bond is represented by two dotted loops. Three center bond is represented by two dotted loop. In each loop there are two boron. In each loop there are two boron and one hydrogen in each loop two boron and one hydrogen okay. The center bond is represented by two dotted loop. In each loop there are two boron and one hydrogen and two electrons, two electrons, okay. Bond energy and bond strength. Next is bond energy and bond strength. Bond. V2H